Morning, everyone. My name is Andrea Auld. I am a training consultant here at Argonaut, and this presentation is about allocations in PCM, which is Profitability and Cost Management, or EPCM, which is Enterprise Profitability and Cost Management, which was released in June of 2022. And the title is Allocations in PCM or EPCM in 50 minutes or less. But, you know, I'll tell you, ideally, although the presentation may take 15 minutes, ideally, it will not take you 15 minutes to actually create and test an allocation. And that's pretty cool. So let me talk briefly, some introductory slides. The first thing about Argonaut is that our mission is to leave the world a smarter place than we found it. And so these webinars are all part of that series. The example that I'm going to use for this webinar is actually the example that we use in our one-day hands-on workshop-filled EPCM course. Argonaut is, or Argonaut as Argonaut Interrel, is a 5-time EPM and Analytics Partner of the Year, something you undoubtedly may be aware of already. And we also have a Net Promoter Score of 77%, which is pretty darn good considering that the average Net Promoter Score is 24%. And that's your Net Promoter Score is a measure of how likely your customers are to recommend you to someone else. And our customers, I think, are pretty likely. And I can tell you that I would have recommended Interrel before I ever even came here. So standard disclaimers apply. These slides represent the work and opinions of the presenter and do not constitute official positions of Oracle or any other organization. And lastly, Oracle EPM Cloud changes potentially every month. And that's actually a fantastic thing. One of the reasons why it's fantastic today is that EPCM, Enterprise Profitability and Cost Management, was just released in June. And so I am going to actually be showing you some slides from EPCM, which is pretty much like PCM, only maybe a little bit more familiar version of the product because it uses things that you're familiar with, like data forms from planning and FCC. So first of all, let's ask the question, why PCM or why EPCM? Like, why would you use these tools? You're probably aware that you can do allocations with business rules, both in planning and in FCC. So why would you do it in PCM or EPCM when you can do it with business rules? And the answer is PCM and EPCM provide a user-friendly interface for building allocation logic that can be used by members of the accounting staff to create and test allocation rules and verify results without the necessity of knowing how to do any coding. So you don't have to know Calculation Manager. You don't have to know how to write fixed commands in your S-based coding language. And you won't need to rely as much on your IT staff to maintain your allocation logic in business rules, because you'll actually be able to have someone do it in your accounting department who understands the concepts of an allocation possibly a little bit better than someone on your IT staff might. So in addition, PCM and EPCM provide some additional built-in analytic capabilities to trace allocated balances from source to destination. Now I'm actually going to stop my video so you won't see me anymore with my cool staircase in the background, which is not my house, by the way. And I'm going to stop the video, but we're going to continue with the slides. So let's go on. So this is a short webinar. So we're going to start off talking about what it is that we would be trying to accomplish with an example of an allocation rule in EPCM. And I am going to show you some slides from PCM just for kind of a data compare of what the differences are. They're pretty mild, but there are some differences. So in our example allocation, we want to allocate facilities expenses balances from the entity to which the expenses were charged to the entities which actually incurred the expense. So expenses are going to be allocated to each entity based on a usage amount, which is the balance in a statistical account, which stores the total square footage for each of the destination entities. So there's kind of two ways to think about the formula. The first one is that you have a cost pool, which is some balance, some dollar amount that you want to allocate. And you're going to, for each destination intersection, you're going to multiply that by some usage amount for each destination, and then divide that by the total usage across all destinations. And that will equal the amount to be allocated to each destination intersection. And in our example, our source is going to be one entity, and our destination is going to be a list of other entities. Now, I want to be a little bit more consistent because I think terminology is really important. So I want to use EPCM terminology. And EPCM terminology is we have a destination or destinations, so destination intersections, and those balances are going to be populated with amounts to be allocated from a source intersection, okay, multiplied by a driver amount, which is coming from a stat account for each destination, divided by the total driver amount for all destinations. And again, my source is one cost center or one entity member of the entity dimension. My destination is a list of members of the entity dimension. And my driver is simply a stat account. Now, everybody likes to see stuff in Excel, and I'm no different than anybody else. So I also do think that it's helpful initially to put what you want to accomplish into a very clear format so that you know exactly where the dollars are coming from, how you're going to allocate them, and where they're going to go to, and what the expected amounts would be. So at the top of my Excel worksheet, I have my source intersection, which is where the balance is that we want to allocate. And in my sample environment that we're using for the example, my dimensions are scenario, year, period, entity, account, and then I have 4 custom dimensions: activity, customer, product, and driver. So the balance that I want to allocate is coming from actual 2021, the January period, the CC 1001 member of the entity dimension, the facilities expenses member of the account dimension, which is actually a parent member in the account dimension. And then for my source intersection that has the balances to be allocated, I have these other 4 custom dimensions. But because they're not really relevant for expense accounts, they're dimensions that I have for measurement of revenue. The member for the source intersection is going to be the no activity member, the no customer member, the no product member, and the no driver member. And just to comment, and I'm going to say this 3 or 4 times, the driver dimension has nothing to do with the concept of an allocation driver in the context of an allocation rule. Right? It's just a dimension that we would use for additional information for a revenue account, but we're not allocating balances from a revenue account, we're allocating balances from an expense account. So our initial balance to be allocated is $8,200,000. Now the driver balances are coming from intersections for each of the destination entities to which we wish to allocate the balances from an account called Stat 1101. Now the name is not very meaningful, but what it actually is it's an account that stores square footage for each of the destination intersections. And so the driver amounts are coming from actual 2021, January, each of the destination entities, CC 2001, CC 3000, which actually has 2 children, CC 4000, etc. Right. The destination intersections, those at the bottom, those are the ones that we want to actually be populated with the allocated balances. So what we're going to do, for example, for target or destination entity CC 2001, we're going to take $8,200,000, which is the source amount. We're going to multiply it by the driver amount for that particular destination entity, which is 450. We're going to divide that by the total of all driver amounts, which is 18,500, So 8,200,000 times 450 divided by 18,500 should give you an allocated balance at CC 2001 of $199,459.46. Now, just a little comment about the destinations. In my Excel worksheet, I show CC 3000 and CC 4000, but those are actually parent members in the entity dimension. So the intersections that will actually get populated are the children, which are CC 3001, 3002, CC 4001, 4002. So that's what we're trying to accomplish. Excuse me. So Enterprise Profitability and Cost Management was released in June of 2022 and has some significant improvements and differences from PCM, including those shown below. Now, for the purposes of this presentation, I'm mostly going to show you screenshots from EPCM with a few screenshots from PCM just for comparison. There was a person from Oracle who gave a presentation last week sometime about all of the newer features and the differences between PCM and EPCM. So I'm not going to go through all of that because you can find that on YouTube. But some of the differences are that we had an older dimension editor in PCM, and in EPCM, we have the familiar simplified user interface dimension editor that you'll be familiar with if you've worked with planning or FCC. In PCM, you mostly had to look at your balances by doing a smart view query that was built by your consultants. In EPCM, we have data forms, which again is more similar and in line with planning and FCC. We have the ability to run reports through management reporting. And we also have the ability to build a dashboard, which will let you have a dashboard with the data form, and then also with one or more charts that are using data from that data form. And you'll see that at the very end. All right, so there are some nice new features, and some of the benefit is that it's going to look more similar to planning in FCC for those of you that are familiar with planning in FCC. So the first consideration is that the dimensions that you're going to reference within your rules must exist in PCM or in EPCM in order to be referenced from within a component of an EPCM allocation rule. Now, there are two dimensions that are unique to PCM and EPCM. They have different names in PCM and EPCM. They're called rule and balance in PCM, and PCM rule and PCM balance in EPCM. Okay, just a slight difference in the naming convention, and for the rule dimension, there's a slight difference in how the members are named. That's actually an improvement. Notice that this screenshot is from EPCM. We're in the application overview card, very similar in PCM, but a lot nicer in EPCM because it looks more like planning and FCC. So a PCM EPCM application has three types of dimensions. The first one is your system dimensions, which are always present as part of PCM. One is called PCM rule, one is called PCM balance, and they are used as part of data intersections in the EPCM environment. So that means you will need to know your members in order to be able to do a smart view query, and they store balances as they move through the execution of an allocation rule or a custom calculation rule, which can also be done in EPCM. Although in this particular webinar, we're just concentrating on allocation rules. We have point of view dimensions, and in our classroom environment, the point of view dimensions are similar to the point of view dimensions you would have in an external planning or an external FCC application. So scenario, year, period, and version. Now in PCM, you did not have to have a version dimension. In EPCM, you do have to have a version dimension. And then we have our business dimension. And in our classroom EPCM application, the business dimensions basically correspond to intersection dimensions that you would have in an external planning or FCC application. So you're always going to have entity and account. And then in our classroom environment, we have four custom dimensions driver, activity, customer, and product. Now, note that those dimensions, driver, activity, customer, and product, would most likely be custom dimensions in an FCC or planning application created to provide additional detail for income statement accounts such as revenue. And I told you I was going to tell you multiple times, the driver dimension in our example is unrelated to the concept of an allocation driver within an allocation rule. And in fact, as I showed you in the example, we are always going to reference the no driver member of the driver dimension in our rule components because we don't measure expenses by driver or product or customer or activity. Those dimensions are only used for revenue accounts, which is not what this example is about. And so first of all, the PCM rule dimension is standard in EPCM and is populated by the names of the rules in EPCM as each rule is created. Now, they made an improvement between PCM and EPCM. In PCM, every time you created a new rule, it would get a rule number, but that wasn't really meaningful. So what they did in EPCM is the members of the PCM rule dimension, which was just called the rule dimension in PCM. In EPCM, the members of the PCM rule dimension actually are the names of the rules. And that makes it a lot easier to pick the members when you're doing a query or you're building a data for. Right? And notice there's a little statement at the end of this. Data is initially loaded to the PCM no rule member of the PCM rule dimension because that's where the data resides before you execute any rules. The PCM balance dimension is also standard in EPCM, and its members are populated by balances as they move through the allocation process. Now, balances are initially loaded to the PCM input member of the PCM balance dimension. And then as you do your allocation rules, it will populate the PCM allocation in member with the allocated balances that were allocated by a specific rule. And the PCM allocation out member of the balance dimension will store offset amounts that cleared the original source balance intersection. So the scenario dimension would normally correspond to the scenario dimension in planning or FCC. The only reason why we have a lot of scenario dimensions is in the class, each student runs their rule for their own scenarios so that everybody's stuff is separate when you're testing. The years dimension would normally correspond to the years dimension in a planning or FCC application. The period dimension would normally correspond to the period dimension in a planning or FCC application. The version dimension would normally correspond to the version dimension in a planning or FCC application. And scenario, year, period, and version, those are point of view dimensions, and we'll see how that's significant in a minute. Now, the entity dimension would normally correspond to the entity dimension in a planning or FCC application. So what we're looking at is we're looking at the entity dimension in EPCM, and you'll notice that we're using the SUI, Simplified User Interface Dimension Editor. Now, realistically, you probably will manage your dimensions and your members and your hierarchies in a metadata management tool like Enterprise Data Management, which allows you to have a formalized metadata change request process with approvals and with property value validations. So for example, in FCC, all members of the entity dimension should have a value for the base currency property. And you can maintain those kinds of property value validations in enterprise data management, as well as having a formalized approval process for adding dimension members or making changes to dimension member properties or making changes to hierarchies. So in the screenshot, you see our source entity, CC 1001, and then you see our destination entities, CC 2001, CC 3000, CC 4000, CC 8000. Now note that the hierarchy maintenance is important because in the definition of your allocation rule, you may reference parent members in the entity dimension or the account dimension, but what's actually going to be populated is intersections that reference their level 0 children. And we'll see that when we see the source definition in our allocation rule. Now, the account dimension would also normally correspond to the account dimension in a planning or FCC application. And notice that we see our source account, which is facilities expense, and take note of the fact that it has 2 children, 2 level 0 children, FAC 8100 and FAC 8200. So our source intersection, there's actually going to be 2 of them. They will both be for entity CC 1001, but then there's 2 base members of the account dimension that will be referenced by the parent that we reference in the source component of the allocation rule. Right, so we have our source account, facilities expense, that's also going to be our destination account. And then we have our driver account, which is stat 1101. And remember that the driver account or the driver component of an allocation rule has nothing to do with the driver dimension in our sample application. Right, so our custom dimensions also need to exist in the dimension editor, and our custom dimensions in the classroom environment are driver, nothing to do with allocation drivers, activity, customer, and product. And in our allocation rule, all the components of all rules within all rule sets within our model are going to reference the no member of the appropriate dimensions, driver, activity, customer, and product, because that's appropriate for our example. So those no driver, no activity, no customer, no product members, they need to exist in dimension management within EPCM. Now, just a little bit about differences between PCM and EPCM. On the left-hand side, PCM had its own dimension editor screen. Actually looks a lot the same. You still see CC 1001 and CC 3000 and CC 4000. And then on the right-hand side, you see EPCM, which uses the simplified user interface dimension editor, which you'd be familiar with from planning or FCC. So again, everything's becoming a little bit more consistent. It looks the same in FCC and planning and EPCM. Across the board, they all use the SUI dimension editor. And again, we have our source entity CC 1001 and our destination entities CC 3000 and its children and CC 4000 and its children. But again, you don't have to manage dimensions within PCM or EPCM. You have a lot more flexibility and a lot more power if you do that within enterprise data management. And we will at some point have a webinar on the basics of enterprise data management, which is relevant not only for our EPM customers, but also for our ERP customers that have segments in their chart of accounts that may correspond to dimensions in their EPM products. So these are the steps to define an allocation rule. I think I made a mistake and I left one step out, but you'll see it when we go through the process. The first thing is we're going to create something called a model. And a model is basically just a set of rule sets and rules that get executed for a given point of view, which would be scenario, year, period, and version. So we will create the model. When we create the model, we will define something called a model context, which identifies dimension members that are common for all components in all rule sets within the model. Then we can create at least one rule set. And when we define the rule set, we can define a rule set context, which will reference dimension members that are the same for all rules within that rule set, but not necessarily for all rules within the model. For an allocation rule, and rules are always either allocation rules or custom calculation rules. This webinar is only about allocation rules, but in the one-day hands-on course, we also do calculation rules. We'll define the rule description. We'll identify whether or not the rule uses the model context and the rule set context. We'll define the source intersection, which is where are the balances we want to allocate. We'll define the destination intersections, which is where are the intersections where we want the allocated balances to end up. We'll identify the driver basis, which can actually either be an account like Stat 1101, which is going to be for our example, or you can allocate balances evenly. And that's another option that we do in the one-day course. And then you define an offset, which is what intersection do you want to populate with the allocated balance multiplied by a -1 in order to clear the allocated balances so that when you go back and look at the source intersection, there's 0. So first comment is we're going to start off with a model. Now, the terminology is slightly different in EPCM than it was in PCM. In PCM, you had something called a point of view, which was scenario, year, period, and version, right? And every time you wanted to do something for a new scenario, year, period, and version, you had to create a new point of view, right? Which included all the rule sets and the rules. In EPCM, they've separated it out so that the model kind of stands alone and can be run for more than one or more points of view, right? Which is a big improvement because that means when you make changes to the model, then when you run the model for a given point of view, your changes take effect in whatever point of view you run it for. So a model consists of one or more rule sets, each one of which is executed in order by the rule set sequence number within the model. Every rule set can consist of one or more rules, either custom calculation rules or allocation rules, which are executed in order by the sequence number within the rule set within the model. And a model can be executed from many points of view, which in our case is a unique combination of members from the scenario, year, period, and version dimensions. And the main thing that's important to get from the screenshot in the slide is that every component of your model, each rule set, each rule, the model itself, has audit information to show you who created the rule, when it was created, who made the last update, and when the last update was made. Now, when you create a model, the model can contain something called a model context. So on the left-hand side of the screen, you see I have a model. It's called the 10 actual model. If I edit the model on the right-hand side, you see the name is the 10 actual model. The description says this is a model file. And then the model context references the no driver member of the driver dimension because that dimension member is common for all intersections within all components of all rules within all rule sets within this model. Now, the waterfall setup in the designer card is our interface for creating and editing rule sets and rules associated with a specific model. Now, PCM had this interface, but then it also kind of had an older interface that was like a little pop-up window. Now everything is in the web interface, so no more little pop-up windows, which is really nice. And again, notice that all artifacts have an audit trail. They show you who created the object, when it was created, when it was last updated, and who made the last update. So we're going to look at one rule set within our 10 actual model, and the name of the rule set is occupancy expense allocations. And this again is the actual example that we use in the class, in the one-day hands-on course. But in the one-day hands-on course, we also do a custom calculation rule in addition to doing 2 allocation rules in the hands-on class. Right, so first off, the rule set definition includes the name of the rule set, the description, the sequence number, which indicates what order does this rule set execute in relationship to other rule sets within the model. Okay, the rule set definition also identifies whether or not the rule set uses the model context, which for our example is the no driver member of the driver dimension, which is common for every intersection or every component of every rule within every rule set within this model. So our rule set is going to use that model context, which is the no driver member of the driver dimension. Right. In the member selections or rule set context tab of the rule set definition, you can specify additional dimension members that will be common for all intersections in all components for all rules within the rule set, but will not necessarily be valid for all rule sets associated with the model. So the model context is dimension members that are common across the entire model, regardless of what rule you're in. Okay, the rule set context is one or more dimension members that will be common for all intersections for all rules within that rule set, but not necessarily across the entire model. And again, remember from our example at the very beginning that all of our intersections, we're going to reference the no driver member of the driver dimension from the model context, and the no activity, no customer, and no product members of the appropriate custom dimensions in the rule set context. So now that we've got our rule set, we can create at least one rule within that rule set within the model. So rules, when they are defined as custom calculation rules. And we do an example of a custom calculation rule in the one-day hands-on class, or an allocation rule. Because this is a short presentation, we're only going to talk about allocation rules in this example, but in the one-day course, we will talk about custom calculation rules, and we will actually build one and test it from scratch. So the rule definition includes the rule name, the description, the rule sequence in terms of what order will the rule execute in within the rule set within the model, and also identifies whether or not this rule within the rule set will use the rule set context, which it doesn't have to, but it saves you a lot of time. So in our example, this rule will use the rule set context, and the rule set context references the no activity, no customer, and no product members of those appropriate dimensions. And then the rule set uses the model context, which references the no driver member of the driver dimension. And note that when the rule is saved, the rule name becomes a member of the PCM rule dimension so that it can be referenced in queries, right? And again, that's more friendly than it was in PCM. In PCM, we had a rule number and you had to know, well, what's the name of the rule with that number? So now they actually give you the rule name as a member of the rule dimension. Now, for an allocation rule, the source tab will specify the dimension members for the intersection from which the balances will be allocated. So on the left-hand side of my source destination tab in my allocation rule, I have a reference to my source entity, CC1001, which had to exist in the dimension editor. And then I have account facilities expenses. Now, notice if you look at the word source in the little blue bar, you see there's the number 2 next to it. And that's to indicate that you actually have 2 source intersections. And that's because the facilities expenses parent account has 2 children, FAC 8100 and FAC 8200, right? So there's actually 2 source intersections, CC 1001, FAC 8100, CC 1001, FAC 8200. And so there's 2 source intersections, and it's the sum of those balances that will be allocated out to your destination intersections. And again, just a little note, any intersection dimension that is not referenced in the tab will be derived from the model context, which in our example is the no driver member of the driver dimension, or from the rule set context, which in our example references the no activity, no customer, and no product members of the appropriate dimensions. Okay, so they're not there because they're coming from the model context or from the rule set context. Now, for an allocation rule, the destination tab specifies the dimension members for the intersections to which balances will be allocated. And again, note that any intersection dimension which is not referenced in the screen will be derived from the model context, which is the no driver member of the driver dimension in our example, or the rule set context, which is the no activity, no customer, and no product members in the appropriate dimensions. Now, if you look on the right-hand side of the screen, you'll notice that the destination account is the same as the source account. And so that means you are allocating from facilities expense at CC 1001 to facilities expense at your destination entities. Okay, but remember that facilities expense actually has 2 children. So there's actually 2 destination accounts. And then if you look at the list of destination entities, some of them are parents. So CC 2001 is a level 0 member of the entity dimension, but CC 3000, CC 4000, and CC 8000 are all parent members in the entity dimension, right? So that's why when you look at the word destination in the blue bar, you see 28. Okay, so there are 28 possible destination intersections. There are 2 accounts, and then there are 14 actually level 0 destination entities, some of which are children of the parent entities that are referenced here in the screen. Now, for your allocation rule, the driver tab, which again has nothing to do with the driver dimension in our example, specifies the dimension members for the intersection containing the driver balance. Now, look closely at the screenshot, and if you squint, you can see that there is an option to allocate the balances evenly, right? We are not going to do that in this example, although we do an example where we allocate evenly within the one-day hands-on workshop. Right? So in our example, we are going to allocate balances based on a driver amount that is stored in that stat 1101 account, which stores square footage for each one of the destination entities, right? And again, intersection dimensions which are not referenced will be derived from the model context or the rule set context, which is why the, why the customer activity, driver, product dimensions, they all say same as destination. And for an allocation rule, the offset tab specifies the intersection which will be populated with the source amount multiplied by -1. And basically what that's going to do is that's going to make certain that your original source intersection is cleared. And after you run the allocation, if you were to look at the source intersection through a data form, all of the intersections would have a balance of 0 because those balances have now been allocated and they're in the destination intersections rather than in the source intersection. Now we have chosen to post the offset to the source location. If for some reason you want to post the offset amount to an alternate location, like a contra account, then any dimension, any intersection dimension where the member is not referenced in this screen would be derived from the model context or the rule set context. Now, for an allocation rule, the validation tab indicates whether or not the allocation rule validated successfully. This tab is not there in PCM, although there is a screen from which you can actually validate the rule. The validation is particularly important when doing custom calculation rules because there are possibilities for syntax errors in the format. Validation for an allocation rule basically assures that the members that you chose in the source and the destination and the driver tabs were actually valid members in that particular dimension. And notice our rule is valid as indicated by the check mark next to validation status. Now, one really nice thing in PCM and EPCM is this mass edit tab. And what the mass edit tab allows you to do is it allows you to, for example, copy an allocation rule, create a duplicate of that allocation rule, and then modify it by perhaps changing the source. So in the one-day hands-on class, we actually create a copy of our model. And then within our model, we create a copy of an existing allocation rule. And then we use this functionality in the copy of the original allocation rule to replace members in the source intersection with new members for a different allocation. You're also able to enable or disable multiple rules from this screen, which is why it's called Mass Edit. You can copy rules from one model to another. You can add members if you want. So let's say that you wanted to add another member in the destination to the entity dimension, you can do that, but you can do it across all of the rules that you chose before you click the actions button. So there's some big benefits in being able to do things kind of in bulk. Now there is a report that documents your model. And again, a model is a list of rule sets, one or more rule sets, each one of which can contain one or more rules. So over on the left-hand side, in the output of the model documentation report, you see we are looking at the occupancy expense allocations rule set. We've selected the rent and utilities reassignment allocation rule. And then over on the right-hand side, you see documentation of the rent and utilities reassignment allocation rule, including the source intersection, CC 1001 facilities expense, the destination intersection, which is the same account, but a list of destination entities, and then the driver basis, which is stat 1101. Now this report existed in PCM. It was just called the program documentation report, and you ran it from a different screen called system reports. So the report is basically the same, it just has a different name and you run it from a different place. Now, a point of view in PCM and EPCM consists of a unique combination of members in the scenario, year, and period and version dimensions for which you want to run the rule. You can create a point of view from scratch, or, and this is what we do in the one-day class, we copy an existing point of view in the calculation control card, which gives us the option of copying the data from that existing point of view. Okay. Now, remember that in EPCM, you have a model which can be run for multiple points of view versus PCM, the point of view itself actually contained the rule sets and the rules. So in EPCM, the model itself is a standalone object, and you can run the model for one or more points of view, each one of which consists of scenario, year, period, and version. Now, let's talk really briefly about data loading, because you're maybe wondering how data ever gets into EPCM to begin with. And we don't really have time to discuss that in detail in a 50-minute webinar. Data loading for EPCM would normally be handled via data management as an extract from a source system such as FCC or planning. You can also import balances from a file. And most importantly, data will be normally loaded from your source system into PCM or EPCM to the intersection of the PCM no rule member of the PCM rule dimension and the PCM input member of the PCM balance dimension. All the other members of the rule dimension and the balance dimension are populated when you run the rules to track allocation balances through the allocation process. And once you have executed your allocation rule and you have allocated balances, you can push them back to FCC or planning via data management. And we do have a one-day hands-on course for data management as well, with workshops in which we discuss data management concepts like system settings, import formats, locations, data load rules, data load mappings, data load workbench, etc. So there is a separate course for that. There is also a webinar out on the Argano website where we kind of go through a data management example that actually corresponds to the one-day hands-on data management course. Now, EPCM, unlike PCM, uses data forms similar to planning and FCC so that balances can be validated via a data form prior to actually executing your allocation rule. Now, in PCM, you probably would have done this with a SmartView query built by your consultants. You can still do this in SmartView. It's just now that you can do it via data form as well. Right? So again, note that data is normally initially loaded to the intersection of the no rule member of the rule dimension and the input member of the balance dimension. And so what we're looking at here is we're looking at data for the actual scenario, year FY16, period January, the working version, and we're looking at the intersection of the no rule member of the PCM rule dimension and the PCM input member of the balance dimension for our source entities, CC 1001, and our source account facilities expenses. And we see the $8,200,000 balance that you saw in my Excel worksheet back at the very beginning. And of course, you could always open this data form in SmartView as well. So source data can also be viewed via something called the rule balancing screen. Now, this was available in PCM as well. In EPCM, the rule balancing screen does require that you create a data form. And there are instructions in the EPCM online help about exactly how to create the data form, which is important because when you create the data form, it helps filter the data in the screen so that maybe you don't see data from every possible intersection or every possible dimension member. You only see data that is actually relevant. So in the rule balancing screen, we are using the rule balancing data form, which I built using the instructions from the online help. We are looking at year FY22. And yeah, I did mix up the years in different screens, so they're not all the same, but the concept is the same. So year FY22, period January, I'm looking at one of my student scenarios and the working version. I click the refresh button and we see the balance over on the left-hand side, $8,200,000 at the intersection of the no rule member of the rule dimension and the input member of the balance dimension, which is where data would initially be loaded. Now notice that there are some other members that will get populated as rules get executed. Adjustment in and adjustment out. Those members get populated by custom calculation rules. Allocation in and allocation out. Those members get populated by allocation rules, right? And then you also see some other members called running balance and running remainder. And those actually store balances that are used by rules after the first rule, right? Because every rule executes in order. And so you may be executing a rule that's only looking at the results of the previous rule. Now, for an allocation rule, and I apologize because I think I'm going to go right up to 60 minutes instead of 50, but still. So for an allocation rule, there is a report called the Rule Data Validation Report. And you could run this from the System Reports tab in PCM. You can run it from the Designer card in EPCM. Very nice report. And notice that what it displays on the left-hand side is the source balances at the source entity and source account, which for us was CC 1001 and the 2 level 0 members of the facilities expense account. It also shows you your driver data. And at the bottom over on the right-hand side, you see that square footage for destination entity CC 2001 is 450, and that's my driver amount. So this is what the report looks like before you run the allocation. You can run the allocation rule from a card called the calculation control card for a specified point of view that you select when you go click the calculate model. So first you pick the point of view for which you want to run the rule, and then you click Calculate Model. Now this card was there in PCM. It was called Execution Control rather than Calculation Control, but otherwise it looked exactly the same. So, and notice it says Calculate Model. So we're calculating the model. We're executing all the rules and all the rule sets for the model for the point of view that we chose. Although in this example, we're not actually executing all rules. First thing is on the right-hand side, you can enter a job comment, job comment. Hey, that will actually show up in the job details to help you figure out which job is the result of you running a specific rule. And then you can choose a processing range. You can run rules within a given rule set. You can run all rules up to a certain point and then stop. In our case, we are only going to run a single rule. And in that case, we identify the name of the rule set is occupancy expense allocations, and the name of the rule, which is rent and utilities reassignment. We can look at the status of the run calculation job in the jobs card. Mine completed with a warning. Ideally, that wouldn't happen, but just want to show you what could happen if you made a mistake somewhere. So notice there is a little warning that says that we have not redeployed since the last metadata update. So it is possible that one of the parent entities that we referenced in our destination now has a new child, but it won't be picked up because we have not refreshed the database. And another little difference between PCM and EPCM, in EPCM, you just execute refresh database, just like you would in planning or FCC. It was a little bit uglier in PCM, but refresh database is what you do after you make a metadata update, like you add a dimension member, for example. Now, you have multiple options in EPCM available from a card called Calculation Analysis. This was basically available from the System Reports menu in PCM. And there were actually 2 reports in PCM. There's only one in EPCM that has all the same data that the 2 reports had in PCM. So there is a report called the Calculation Statistics Report. Very useful. Thank you, Stan Ziolkowski, wherever you are. This is particularly useful because it allows you to tell if you look and your results don't look quite right, you can run this report to verify that cells actually were updated. Maybe not the ones that you thought were going to be updated, but cells were actually updated. So over on the left-hand side, you see potential sources, you see potential destinations, you see the number of cells that were updated is 30. And then over on the right-hand side is some performance information that is related to S-based performance statistics. Now, once you have executed the allocation rule, you can go back and rerun that rule data validation report after execution of the allocation rule. And notice that my source balances are now 0 because all of my amounts have been allocated. I did not show the driver data section of the report because that's not affected. My driver balances in the Stat 1101 account, those are still there, but my source balances have been allocated out. So now they're 0. And you're looking at this, if you're squinting really hard and you're looking closely, you'll notice that it's not 0. So I think there may be a little bug in this, but it is what Carol Krajewski, one of our architects, would refer to as penny dust. I love that term. Anyway, so this may be a little bug in the report, but still the source balances after the allocation are 0. And in EPCM, you can build a data form to display the allocated balances at the intersection of the rule name member of the PCM rule dimension and the PCM allocation in member of the PCM balance dimension, which is populated with the balances to which the allocated amounts were written. So if you look closely at the data form, So this is for actual FY16 January working. The first column, we are looking at the initial balances at the intersection of the PCM no rule member of the rule dimension, the PCM input member of the balance dimension for account stat 1101, which is the driver account for all of our destination entities, which had a balance before the allocation, and then facilities expense for CC 1001, which is the initial balance at the input member of the balance dimension to be allocated. Now there is kind of an unneeded column in here, but I left it in there. The heading of the unneeded column is called Utilities Expense Adjustment. And that's actually a custom calculation rule that adds $330,000 to the facilities expense account to increase the balance to be allocated from $8,200,000 to $8,530,000. Okay, and then the last couple of columns are specifically for the rent and utilities reassignment rule, which I just executed. The PCM allocation in column shows the balances that were allocated to the destination intersections. The PCM allocation out column shows the offset amount that cleared the original intersection with the source amount. And again, you could open this in Smart View, but this is kind of nice because it's a lot better than having to build a custom Smart View query. You have the data form, or you could open the data form in Smart View if you wanted to. Now, one of the other cool things about PCM and EPCM is something called the trace function that is available in the intelligence card. Now, a difference between PCM and EPCM, and by the way, I am almost done. The difference between PCM and EPCM is in EPCM, in order to use the trace function, you actually have to build a data form, but there are very explicit instructions on how to build a data form for the trace function in the EPCM help, just like there are explicit instructions on how to build the data form that you need for the rule balancing screen. So notice over on the left-hand side, you see the original balance to be allocated, and then over on the right, you see all of the allocated balances for the individual destination entities. And I just highlighted CC 2001 just to show you that is one of the destination intersections. And lastly, I think this is the last slide, in EPCM, because it's now a lot more like planning and FCC, and it uses data forms, you also have the ability to build dashboards. And dashboards will display allocated balances in a data form and can also display it in multiple chart types, which use that same data form as a data source. So over on the right-hand side in the dashboard, you see a data form called Allocation Trace. It shows you all of the allocated balances at the destination intersections, CC 2001 through CC 8400. And then on the top left, you see a pie chart of data from that data form. And on the bottom left, you see a bar chart of data from that data form. And if you were lucky enough to attend Wayne Van Slees's K-Scope presentation or the masterclass presentation, which is available on YouTube, he also shows you how to use EPCM as a data source for Oracle Analytics Cloud. So kind of another new feature that is available now that we have EPCM. So Interrel offers a one-day hands-on workshop for, or a one-day hands-on course with workshops for PCM or EPCM. You can take it in either environment, but it's probably better if you take the EPCM version. This is a list of the hands-on workshops. Note that the one-day course includes hands-on workshops for custom calculation rules as well. So we do discuss dimension management. We review the course example. We review a model rule set. We create a point of view. We validate our input data. We create and execute a custom calculation rule, which makes an adjustment. We create and execute an allocation rule and view the results. Then we create a new model using the mass edit function, and we create a new allocation rule, and we allocate balances evenly rather than using a driver with a different source and a different destination. We execute the new allocation rule. We view the rule results in a data form. We talk about undoing a rule. We talk about the trace allocations interface, and we also create something called an analysis view. And remember also that we do have a one-day hands-on workshop for data management, as well as a webinar out on the YouTube channel. All right, so so much for 50 minutes or less, maybe 59 minutes or less. I'm going to stop sharing. Brianna, do we have any questions?
I did not see any questions roll through, so we are good to close it out.
Okay, I do believe, Brianna, they have a way of getting hold of us if they do have any questions, I believe, and someone will get in contact with them. Is that correct?
Correct. So if you do have questions, or if questions come up later in the day, maybe later in the week, you want to email info@interrel.com and we will get those answered within 24 hours.
All right, everybody, have a great afternoon.
Yes, have a great afternoon, everyone. Thank you so much for joining us today.